Welcome back. In this lesson, we're going to look at the classification of igneous rocks. Igneous comes from fire, so this is melted rocks. This is rocks that used to be magma. Some of this magma is going to find its ways to a vent and actually come out onto the Earth's surface, and that would be lava, and that vent would be called a volcano. But there's lots and lots of melted rock under the Earth's surface that never actually reached the Earth's surface. So these are magma chambers, and the magma is got different stuff in it. Different rocks are melted. So there was a rock that then melted and then re-solidifies into rocks. What's in it can classify igneous rocks. How slow that it cooled off or how quickly it cooled off, depending on whether it came out into the air or the water or stayed in the ground to cool off. All of this will contribute to knowing something about what type of rock you have, whether it's the recipe, whether it was the temperature of the magma when crystals started coming out of them. So we'll look at some of the examples of this. So as we're looking at igneous rocks, remember, are anything that used to be inside a volcano. And so a volcano is just a vent pipe, really. Under the ground, there's large areas that are under such pressure and high temperatures that the rocks are melted. And so melted rocks are called magma. And magma can cool again. So if the hot spot is removed, that magma can cool back down into what you see as a solid rock. Now, intrusive rocks and extrusive rocks just mean, did that magma cool very quickly or very slowly? So let's imagine the scenario where magma comes out of the ground, and now of course it's called lava, and when it reaches the air or reaches the water or reaches the ice or whatever is in the environment, it very quickly cools down. Okay, that is called extrusive rock because it's extruded. The lava is squirted out of the ground. That's extrusive. What you're going to see with extrusive rocks is that extrusive rocks, since it's cooled down very, very quickly, the grains or the crystals in those rocks are very, very tiny. It didn't have time for the crystals to grow. So if you were to have an experiment where you were trying to grow crystals, maybe salt crystals, you might have to let that experiment sit on the shelf for a month before you would have big enough crystals to where they looked like big salt crystals or sugar crystals. If you checked it in a day, you might not have any, or you might have tiny, tiny, tiny little crystals. Well, that's exactly what's happening. If the magma is all melted and then it cools very, very quickly, it doesn't have time for those crystals to grow. So the crystals are tiny. So extrusive rocks are going to have small grains. Intrusive rocks is the idea of in the ground. Let's imagine that you have a magma chamber in the ground and it cools down. The heat source has been removed and it cools down very, very slowly. Okay, so it's 1,000 degrees, and then it's 990 degrees, and then it just keeps getting slowly down. Well, eventually all those crystals will come out of the solution and crystallize, and they have a long time to get big. So when you look at a rock that has large crystals, that's an igneous rock. You know that it was a long time in cooling off, so it must have cooled off underground and solidified or re-solidified into a rock. Now, the minerals that come out is based upon how hot the lava is. So let's say that you have, a melting point for a certain mineral, and then a different mineral has a higher melting point, and then a different mineral has an even higher melting point. All right. So let's look at the left. Cooler magma. So let's go backwards. Let's take the hotter magma. Let's say you have 1,000 degrees. And at 1,000 degrees, certain minerals will start crystallizing out. They've given you some examples. Pyroxene, olivine, labradorite, hornblende. These are minerals that will come out as crystals at very high temperatures. Okay? As you come back, medium temperature, so it's cooled off, Now you get plagioclase out, you get biotite out, okay? Then, if it cools off even more, then you get the quartz out. So quartz is such a huge molecule, okay, that it takes a long time for it to crystallize out. So it's cooler magma that crystallizes out and you get larger grains. So if you add those two things together, that certain temperatures will give you certain minerals to come out, and those minerals have different colors. Okay, the hotter minerals will give you dark colors. The crystals that solidified out at a cool temperature will give you light colors. And if they cooled in the ground, you get big grains, and you cooled out of the ground, you get small grains. You can put those together and know a huge amount. Just those 6 things can let you know dozens and dozens and dozens of rocks. So the rest should be a little bit of a review. If it's rapidly cooling, okay, very quickly, extrusive, out of a volcano, then you're going to have little tiny crystals. If you're going to have slow cooling, then you're going to have large crystals. And then porphyritic means that you're going to have large and small in the same rock. So let's say one crystal comes out at a high temperature and the other crystal comes out at a low temperature. Okay? So as that magma is cooling, the first crystal will come out and have a long time to crystallize. Then the next one will come out of the lava or out of the magma and might only have a short time to crystallize. So it's very possible that in the same sample of rock, in that same neighborhood, you'll have a large crystal next to a small. That's called porphyritic. Vesicular means vessels. So those are air spaces or gas spaces. So you had bubbles. You had gas bubbles in that lava, and as it cooled, the gases were trapped, just almost like bread, where you have the gases from the yeast. The yeast burps up gases, carbon dioxide, and then it gets trapped in the bread dough, and that's what gives the bread its lightness. You're going to have that with rocks too. So a vesicular rock is going to be very light. In fact, pumice stone, which comes from volcanoes, is so light that it would float on water. It's actually, even though it's a rock, water is denser than this rock, and it'll float. So mafic rocks are dark colored with low silica. So it was very hot lava, and these crystals crystallized out of the lava. Okay, so let's say that you have a big pot of lava, and as it's cooling, certain crystals stick to the sides. Well, these guys would be the first to stick to the sides. They're going to be really dark because it has lots of iron in it and different metals in it, so it'll be very dark, and this is called basaltic. Now, basaltic lava doesn't have a lot of silicon in it, so it's very runny. So this would be like Hawaiian Island volcanoes. The next one is granitic. Granitic is light, and it has lots of silica in it, so there's lots of quartz in it. So it's got quartz in it, it's got mica in it, it's got hornblende in it. And so lots of people will make maybe their kitchen countertops out of this because, first of all, it's a very hardy stone, and it's very, very dense, it's very heavy, and it's very hard. So it would make really good counters. This is pretty cool. Thin sections, there's people that's all they do. In order to truly identify what's in a rock, you need to look at it on the microscopic level because one mineral is sitting next to another. And you could have, in a rock, you could have many, 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 many minerals in it. And so to know exactly what's in it, you would need a very thin shaving of that rock that you would do on a really special saw, and then put it through a microscope, and the light is able to come through it, and you're able to say, oh, this is this mineral, and that's that mineral. That's pretty cool. Also, you can have very heavy metals, say gold and silver, that's very dense metals that are in volcanoes, and as these rocks crystals are crystallizing out, you can also get veins. Okay, so you can have veins of gold or veins of copper, veins of silver coming out in these igneous rocks. And then pegmatites are crystals that grow very, very large as veins. Okay, so you can have gemstones, for instance, that are growing inside a rock, but there was enough of that mineral and enough time for it to grow that you could have these crystals, beautiful gem crystals that are growing in it. Kimberlites are also crystals that grow in rocks, but usually under very, very high pressure. And a lot of times diamonds will do that. You can have kimberlite diamonds. They're called kimberlite pipes. And then igneous rocks are so hard, normally because of they took so long to cool off, that you can use them in stone. Okay, so you can have lots of these kind of igneous rocks, granites, would make it very, very strong, hard building.